Hi, we'll be solving a question about modeling inequality. Chelsea has $45 to spend at the fair. She spends $20 on admission, $15 on snack. She wants to play a game that costs 65 cents per game. Determine the maximum number of times X Chelsea can play the game. Okay, she has $45 and she must spend less than or equals the amount of money she spends at that day must be less than or equal to $45. It cannot exceed the 45. Let's set up the equation. X is the number of the maximum number of times she can play the game. So the number of games. All right. She spends, first of all, she spent $20 and $15 snacks and admission. So she spent a total of 20 plus 15, that is $35. Okay. So she spent $35 plus the number of games the maximum number of games that she's going to spend or to play. 0.65 times x must be less than or equals to 45. Okay, let's solve this inequality here. Subtract 35 from both sides. You get 0.65x less than or equals 10. Then you divide both sides by 0.65, divide by 0.65. So you got x less than or equals, we need to find 10 divided by 0.65. No wonder this kind of question here is testing your ability, number one, on understanding inequalities. Number two, dividing numbers by decimal numbers. So you should go back and review dividing numbers by decimals. Let's do it here. 10 divided by 0.65. But before I do that, if we multiply the top by 100 and the bottom here, or the denominator, by 100, you will get, let's write it here, you will get 1,000, 100 times 10, but divide by 65. And that's what we're going to write here. 10 is, instead of 10, we're going to have 1,000 divided by 65. Now let's divide now. 10 divided by 65 does not work. 100 divided by 65 equals 1. 1 times 65 equals 65. We just used the 100. Subtract 100 minus 35 equals 35. You put the 0 down, so you got 350 divided by 65 equals 15. 15 times 65 is 5 times 5 is 25. You got the 2 on the side. 5 times 6 is 30, plus 2, that is 32. Subtract 350 minus 325, you got 25. Now 25 divided by 65 is not going to work. You're going to add a 0 here. Let's get the blue marker. 0 here. So 250 divided by 65, in this case you would have to have the decimal, all right, and you will get a number here. The number is 3. 3 times 65 is going to be whatever the number you get, and then you finish this question. But anyway, you're going to have a decimal number after the 15. So x is less than or equals to 15.3 whatever. All right, we don't care and we don't need the decimal number. Let's go back to the question here. Determine the maximum number of times X Chelsea can play the games. So you have 15.3 games. Of course, she cannot play a part of a game. She has to play either 15 or 16. So have either X equals to 15 or X equals to 16. Unfortunately, a lot of the students do this question here and at the end pick 16. The answer is not 16, the answer must be 15 because she must spend less than or equal to a 45. Less than or equals to a 45. So if she spent 15, she plays 16 games, she will exceed the 45. But if she plays 15 games, she will have a little bit of money left over with her. This one is a one way to solve this question. The other way is it's very similar to this one. So there's no way you get away. There's no way you can solve this problem without dividing the decimal number. She has 45, spent 20, so we can get the black marker. 45 minus 20, that is going to be 25, and then 25 minus 15, all right, that is going to be $10 left over. So you're going to divide the $10 by 65 since the number of games, and that's another way to solve it, but you have to do the decimal number. Work well.